All right, so today we're doing 9-2 characteristics of quadratic functions. The top says review. So if you could pause for like 1 minute, 30 seconds to a minute just to write down everything we've learned so far the last 2 days over quadratics. All right, so I'm going to review some of the things. So we learned that this is called a parabola. We've learned that if the parabola is facing upward, that a is greater than 1, so it's a positive. Also, that point is low, and that point is called a minimum. That's I, minimum. We also learned that if the parabola is facing downward, that means a is less than 1, so that means a is a negative. This point is really high, and it's called a maximum. We learned that that point in the middle is called the vertex. Also, the line that goes through it. Hopefully some of you remembered that one. That is called the axis of symmetry. For the maximum, the value is the y value. I'll just put blank, comma, y value. So the maximum and minimum, and that's a blank, guys. This is blank. Oh, I should just put, I want blank because I don't want to put the x, comma, y. So the maximum is a y value. For the axis of symmetry, that is our x value of the vertex. And we find it by doing negative b divided by 2a. And so that's pretty much everything we've learned. We've learned about parabolas. If it's greater than 1, it's a positive. If it's a low point, it's a minimum, and that represents the y value. We learned how if you cut it symmetrically down the middle, so that basically the left side mirrors the right side. That's the axis of symmetry, which is the x value of your vertex. X equals negative b over 2a. That middle point is the vertex. If it's flipped over, that means that the a is less than 1, it's a negative, and the middle point is the maximum. I don't think I left off anything we learned on 9-1, but if I did, then good, you remembered it. Make sure you jot it down. All right, roots, zeros of a function, and the solutions. It's basically the answer, guys. It's the x values. We learned about zeros back when we learned about intercepts. We know that's the x values. Roots, we learned about that too when we talked about intercepts, and functions of solutions. So that's basically just the answer of your problem, or basically where the parabola crosses the x-axis. So the root solutions or zeros is where the parabola crosses the x-axis. There are 3 different possible solutions that we're going to look at in example 1. It says find the zeros of each quadratic function from its graph. Check your answers. If we look right here, it's crossing the x-axis right there and right there. That first point is negative 1, 0. The second point is 2, 0. And so, focus. Come on, focus. Why is my focus off? I don't know, I'll zoom in. Okay, so find the zeros of each quadratic from the function. Check your answers. So we have 2 zeros in this problem because it crosses the x-axis twice. Everybody got it? If you remember in our last unit when we factored, we took this problem, we factored it, we found our factors, and then remember I said how it's going to lead us to where it's crossing the x-axis on the problem. We're actually doing that on our next lesson tomorrow, where we're actually going to look at quadratics by factoring. But we're leading up to basically connecting it all. Here's our next graph, negative 2x squared plus 4x minus 2. We see that it is crossing right there at, where's my pen? 1, 0. So we have 1, 0. Everybody got that? So it crosses the x-axis once. And you know what? I'm going to take you there. So if we were, we'll just take it a step further and we'll learn tomorrow. If we were to look at B and to actually factor that, what would be the first step? Hopefully you said GCF. Y'all learned that from your last test. Factor out the GCF of -2. And what does that leave us with? X squared minus 2x plus 1. Because if we distribute that, that would give us -2x squared. Two negatives make a positive 4x and a -2. Yes. And so when you look there, it's a perfect square. Everybody see that? And so remember I said on our last unit, perfect squares cross the axis one time. Talk about it a little bit more in depth tomorrow. And then if we look at this final function, 1/4 x squared plus 1, there are no zeros. Doesn't cross the x-axis. So this is an example of root solutions in zeros. 2 zeros, 1 0, doesn't cross the x-axis. Everybody got it? All right, example 2. Solve x squared minus 4x plus 3 equals 0 by graphing. Check by factoring. So by graphing this, remember we talked about the C. Oh, that was one thing you could add up here. How did I forget the main thing? Standard form. I'm sure someone called me out on it. Standard form is ax squared plus bx plus c, and the c represents our y-intercept. That, of course, is very important. That says it all. That was one thing. So add that to your top of all your review of what we learned in one lesson. So we have x squared minus 4x plus 3. So if we were to graph, we know this is our y-intercept. So that could be one point that you could put on your graph. 1, 2, 3. Just because that's the y-intercept does not mean that that's the vertex or the middle point. That's just the point that's on the graph. We don't know what the vertex is going to look like yet. So step 1, we're going to find our vertex by finding x equals -b over 2a. We have to find our x value. If we look at our equation, a is 1, b is -4, and c is 3. We're going to plug in our x equals -b over 2a, and that gives us x equals a -4. Those two get married to become a positive. 2 times 1. We get 4 divided by 2, so our x value of our vertex is 2. Step 2, we're going to take x equals 2 and we're going to plug it back into the original equation. So instead of x squared, we have 2 squared minus 4x, so we're going to do minus 4 times 2 plus 3. 2 squared is 4, minus 8 plus 3. That's basically going to give us 7 minus 8, so our y value is going to equal -1. Everybody got that? All right, so now we know that our vertex is at an x value of 2 and -1. So now I'm going to come over here, -2, no, not -2, +2, -1. And so that is my vertex, or basically my axis of symmetry goes to x equals 2. And so since I know my y-intercept was over here, that's 2 points away from the vertex. So I'm going to go 2 to the right, and there's my other point. Everybody got it? So that's what my parabola looks like. It also says to check, and I'm going to connect it in a second after I check it. Check by factoring. So let's go ahead and check it. So we have our quadratic equation, x squared minus 4x plus 3. If you were to use your chart, remember our chart is A times C equals B. And our A times C is just basically 3. Which factors of 3 will get us to, sorry, it's ugly. Oh, so ugly. And I'm being ugly again. There you go. A times C will get us to our B value. So that would be which factors of 3 will get us to -4. So we know 1 times 3, because it's a prime number, the only 2. We have a sign of a negative. A negative times a positive is a negative. So both of our signs are going to be negative, so it becomes -4. So that means in our parentheses we have an x minus 3 and an x minus 1 in both parentheses. And so when we check by factoring, remember with factoring we set each one of those terms equal to 0. Add 3 to both sides. On this one we add 1 to both sides. And so x equals a +1 and a +3. Right? So then we can come over here and add those points on our graph. X is going to be a +1 and 1, 2, and a +3. So now we have more points on our graph because remember factoring gives us our zeros, our roots, our solutions, or our 0. I'm going to actually just write that under there just so you can remember that's your roots, solutions, or zeros. So we're crossing the x-axis at 1 and 3. And so now I'm going to fill in my parabola. And that's what it looks like. So if you need to take your time to pause it, read through it, understand it. All right, I got a different color just so it won't run into this over here because, you know, I hate stuff just running all into each other. So we have x squared equals -8x minus 16. We have to get this in standard form, so we're going to have to add 8x and add 16 to our right side. So then that gives us x squared plus 8x plus 16 equals 0. If we look, our y-intercept is going to be 16. So 16 is going to be off this graph, so I'm going to count by 2s so that it can fit on my graph. So make sure you write whatever you're counting by. So I know my y-intercept is going to be 16. So 2, 4, 6, 8, 10, 12, 14, 16. So there's my y-intercept, and remember I'm counting by 2s. That's why it's fitting on the graph. All right, now I'm going to come over here. We have x equals -b over 2a. Step 1, finding the x value of my axis of symmetry. So I have -8 divided by 2 times the a, which is 1. -8 divided by 2 gives us -4. So my axis of symmetry is x equals -4. Everybody got that? Pause it if you need to absorb it. Then step 2, I'm going to find the y value of my vertex by taking that -4 and plugging it back into the problem. So I end up with -4. And remember, you have to put in parentheses if you type in your calculator so that it squares all of that. Plus 8 times -4. Let's make parentheses. Plus 16 equals 0. -4 times -4 is 16. Minus 32 plus another 16. 16 plus 16 is going to give us 32. Minus 32 is going to give us, wait, let me double check. 6 and 6 is 12. 22, 32. Yep, just double checking so I don't make a mistake. Equals 0. So y equals 0. So then when I come over here to write my vertex ends up being -4 was the x value that we originally saw for, and 0. So that gives me 1, 2, 3, 4. -4, 0 is my vertex, so my axis of symmetry cuts this in half equally there. It's only crossing the x-axis once. What do we know about when it crosses the x-axis once? Hopefully